Hi, I'm Tomasz Limisiewicz from Charles University Prague. I will present ÚFAL submission for cognate detection task. Let's start with some definitions shown on this slide. So cognates are pairs of words in different languages which have similar meaning and come from the same root in some previous language. While derivatives are direct borrowing from one language to another. For this task, we are given 200,000 pairs of bilingual words together with their relations, cognates, derivatives, or no relations, based on the data from Wiktionary. The data covered 34 European languages, and the evaluation was done on over 800 test pairs for which we didn't know the labels. For validation purposes, I sampled 10% of training dataset. For the task, I used gradient boosted tree algorithm, specifically XGBoost. This method ensembles predictions of multiple decision trees which are found based on gradient search. I use this method because it is applicable for the data described by both discrete and real features. Also, the predictions of this method can be interpreted with feature importances. For hyperparameter search, I used Bayesian search in search ranges shown here and finally selected the values shown in the table. I used three types of features. The first, embedding from transformer models. One, subword-based XLMV, and second, character-based canine. I used PCA to pick 16 components for each of the embeddings. I used language and language group identity. I used character level information, Levenshtein distance on character level between the pairs of words, and the information whether one of the words is capitalized, because often derivatives came from proper names. My model scored 87% F1 on test set. In this accumulation analysis, we see that only language identity is a good predictor of cognacy. It's important to include character level signals such as Levenshtein distance, 5% improvement, and embeddings, including character-based, 10% improvement. And lastly, it's important to weight the labels to counter other representation of cognate relations. It improves F1 score on validation stat. The most important feature was whether one of the languages in a pair is Latin. It is because Latin is source of derivatives in many European languages. It's followed by character level features, Levenshtein distance, and information whether the word is capitalized. The next features are principal components from canine. It's interesting that the order of the components doesn't follow the order of main components from PCA. The other important features are components of XLMV, some language identities, and language group identities. In summary, I showed that only language information is a strong predictor of cognacy. It's important to include character level signals in form of embeddings, canine, and Levenshtein distance. I'd like to extend this method by adding more features, for instance, phonetics and typologically based. Thank you for your attention. I'm looking forward to hear your questions and suggestions for improvement in person.